Okay, 2-7. Square roots and real numbers. Let's talk about square roots. First, some terminology. This symbol is called a radical. Sometimes we call it the square root sign, but it's actually called a radical. The number underneath the radical is called the radicand. Now, all numbers have two square roots. Okay? They have a principal or positive square root and a negative square root. So, the square root of 25 is positive 5 and negative 5. Sometimes it will ask you to give all the square roots or both square roots. Sometimes it will ask you to give the principal square root or the positive square root. What makes them square roots is 5 squared equals 25. 5 times 5 equals 25. And negative 5 squared also equals 25. Negative 5 times negative 5, a negative times a negative is a positive. Okay, here is the square root of 36. Which part of this is the radical? If you said this part, you would be right, radical. Which part is the radicand? The radicand is 36. Okay, what is the principal square root of 36? That would be 6, because 6 squared equals 36. What is the other square root of 36? That would be negative 6, because negative 6 squared equals 36. Negative times a negative is a positive. Now, in algebra, one way we know which square root they're asking for is they use some symbolism. Notice, this has nothing but the radical and the radicand. When you see that, you know that they just want the regular principal positive square root, which is 10. When you see a negative out in front of the radical, like this, and they're asking about square roots, they're asking you for the negative square root. So, what's the negative square root of 9? Well, that would be negative 3, because negative 3 times negative 3 makes 9. When you see it written like this, with a plus and a minus sign, it's asking you for both square roots. So, in your answer, you would say 7 and negative 7. Both of those are the two square roots of 49. Here is the first part of video homework. Get that done and then turn the video back on, continue the lesson, and watch for part 2. Perfect squares. These numbers that I have listed are considered perfect squares. There are more of them. I didn't write them all down. You'd be writing from now till forever. But I wrote down the first several common ones. They're perfect squares because when you take the square root, you get an integer for an answer. You see, every number has a square root, but most numbers are not perfect squares, and so they don't have an integer for a square root. These numbers have integers for square roots. For instance, what's the square root of 1? Well, it's 1. What's the square root of 4? 2. What's the square root of 9? 3. What's the square root of 16? 4. What's the square root of 25? 5. What's the square root of 36? 6. What's the square root of 49? 7. What's the square root of 64? 8. See what I'm doing? Now, let me ask you a question. What about the square root of 2? Where would the square root of 2 go in this list? The square root of 2 would go somewhere in between here, 1 and 4, right? So we're getting ready to decide that. So think about perfect squares and their square roots are integers. Okay. Sometimes you have to approximate a square root. If the book is asking you to approximate a square root, that's called approximating a square root, because you can't get an exact answer on the square roots that aren't perfect squares. So you can use your calculator, or there is a table of squares and square roots in the back of our textbook on page 957. When you go to page 957 and look up the square root of 32, it says 5.657. Now, that is not the whole number. They have chosen to round it to the thousandths place, because the square root of 32, since it's not a perfect square, it's an irrational number, and it keeps going forever, and it never repeats. It's a non-repeating, non-terminating decimal. All the square roots that are not perfect squares are non-terminating, non-repeating decimals. So they have to round them. Now, in our book, when it asks us to approximate a square root, it will always say, approximate a square root to the nearest integer, or to the nearest tenth, or to the nearest hundredth. It's telling you where to round it. So if I were going to approximate the square root of 32 to the nearest integer, I would look at this number and go, 6 rounds up, so that is approximately 6. If it asked me to approximate it to the nearest tenth, I would have to look at the hundredths. And I would say, oh, that's 5, so it rounds up. So 5.6. Remember, you always look at the number 1 over from the number you're rounding to. If it said approximate it to the nearest hundredths, I would look at the 7 and say that rounds up. So, wait a minute. Let me back up. That's 5.7. I just rounded that wrong, because that would round up. Okay. Now, look at the 7, and that would be 5.66, because the 7 would make it round up. Okay? So, make sure you're paying attention to where it says to approximate it to. Integer or whole number, that's the same thing. Tenth, hundredth. Where is it saying to approximate it to? And then make sure you're rounding correctly. Okay? Okay, here's the second part of video homework. You'll need your book for this part. Make sure, besides the rounding, when you're doing this, you have to also look and see, are they asking you for the positive or principal square root? Are they asking you for the negative square root? Are they asking you for both? When you get done with this, continue the lesson. There's another part of video homework coming. Okay, real numbers. Real numbers are all the numbers that you're going to use in math this year. They're all in a big group called real numbers. Now, inside the group of real numbers, there's some subgroups. First, there's whole numbers. Whole numbers start at 0 and go 1, 2, 3, 4, 5, all the way to infinity. It just keeps going and going and going like the Energizer Bunny. Integers are all of the whole numbers plus all of the negative numbers that are like whole numbers. So, everything negative going this direction and everything positive going this direction, all of the integers. So, if you are an integer, you're also, if you are a whole number, you're also an integer. All the whole numbers are also integers. Now, rational numbers include all of the whole numbers, all these, all of the integers, all these, plus fractions and decimals and square roots of perfect squares only. So the square root of 49, which is 7, would be rational. But the square root of 2 would not be rational. The square root of 2 does not give me an integer answer. It's not a perfect square. Now, irrational numbers are also real numbers, but they don't have any of the other groups with them. Irrational numbers, they don't include whole numbers. Irrational numbers don't include integers. They don't include rational. They're irrational. The only things that are irrational numbers are non-repeating, non-terminating decimals. And the only things that fall into that category that actually are like that are the number pi. Okay, that's irrational because we use 3.14, but it's 3.14. I don't know any of the other numbers, but it goes forever and ever. And it never repeats and it never terminates. It just keeps going. Pi is irrational. The other numbers that we know about that are irrational are all square roots of numbers that aren't perfect squares. So that means the square root of 2, the square root of 3, the square root of 5, the square root of 6, the square root of 7, the square root of 8, the square root of 10, the square root of 11, and so on and so forth. All of the square roots except the ones that are perfect squares, because they have integer answers, are all irrational. All of these are irrational. That's all there is in irrational. Pi and those square roots. Now, let's see if we can look at some actual numbers and decide which category they go in. Okay, look at this chart. Look at the number square root of 24. What in the world is the square root of 24? Well, if you punch it in on your calculator, or if you use the chart in the back of the book, you're going to find out that it doesn't come out to be an integer, so it's not a perfect square. So what are all square roots that don't come out to be perfect squares? Well, they are irrational. So it's definitely an irrational number. Now, remember that all the numbers we use in math are real numbers, so it's also a real number. It's real and irrational. Okay? That's all. It's not a whole number. It's not an integer. It's not rational. Because remember, square roots that don't come out to be perfect squares are non-terminating, non-repeating decimals. They never end and they never repeat. They just go on and on forever. Okay, what about the square root of 100? Well, the square root of 100 is 10. Okay? 10 is a whole number. Is 10 an integer? Is it sitting on my number line? Yes. Is 10 irrational? No, it's a perfect square. Is 10 rational? Yes, because I already told you perfect squares were rational. Is it a real number? Yes. All the numbers we're working with in math are real numbers. In fact, I could go ahead and fill this column in because they're all real. All the numbers we're working with in math are real. Now let's do the negative square root of 81. What is the square root of 81? It's 9. Is it a perfect square? Yes. So it's negative 9 because they want the negative version, right? So it's a perfect square. Is it a whole number? No, all whole numbers are positive. They start with 0 and go 1, 2, 3, 4, 5 like that. Is it an integer? Is negative 9 on the number line? Yes, it's an integer. Okay. Is it irrational? No, because it's a perfect square. Is it rational? Yes, all perfect squares are rational. Now let's look at the number pi. Pi is 3.14 and lots of other numbers. It never ends. It never repeats. It's irrational. Pi is an irrational number. Is it an integer? No. Is it a whole number? Of course not. Is it rational? No. How could you be irrational and rational at the same time? That makes no sense. Now look at the chart. Notice, if you are an irrational number, according to this chart, the only other thing you can be is real. Look, both of the irrational numbers were irrational and real. But when you're a rational number, you're always real. You're real and you're rational. When you're both of those, things can be different over in this area, but you're never going to fill these in because you're either rational or irrational. Okay? Just like people. Most people are either rational or irrational. Okay, let's look at these numbers. Let's start with negative 9 over 2. Is it real? Yes, it's definitely real. Is it rational? Yes, fractions are rational. Is it a whole number or an integer? No. So that's the only answer for that. 5.2. Is it real? Yes, all the numbers we're working with in math are real. Is it rational? Yes, all decimals that are normal decimals, they're just rational. Okay? What about, is it an integer or a whole number? No. Decimal numbers aren't whole numbers. They're not integers. What about 0? Is 0 a real number? Yes. Is it rational? Yes. Is it a whole number? Of course. Is it an integer? Yes. Okay. Square root of 7. Does square root of 7 come out to be an integer? No. It's some awful repeating number that never ends and never stops. Non-terminating, non-repeating. Remember? Never ends, never stops. Just goes on and on forever and no pattern. Is it real? Of course, all the numbers we work with are real in math. Is it rational? No. So if you're not rational, you must be irrational. Can't be whole or integer. Real and irrational stops. That's the end of the trail. Good news! Here's the last part of your video homework. Page 112, number 9. Don't do the part that says put them in order. Just worry about 4.1 and negative square root of 20. And just tell what kind of numbers they are, because we did the other part already. We did the other numbers in this list on the example. Have a great night. See you tomorrow.